Okay, welcome to part 2 of calculating speed and velocity. So in this part, we're going to look at calculating velocity when you are not given displacement. If the total displacement is not given in the question, then it must be calculated before solving for velocity. Note, when calculating displacement, you must use positive or negative signs instead of direction symbols. Here's an example. An object is 10 meters east of a fire hydrant. 20 seconds later, the object is 10 meters west of the fire hydrant. Calculate the average velocity of the object. So we can start by drawing a diagram for ourselves to help us understand this better. So you have a fire hydrant. Let's suppose it's here. Now, at the initial position of the object is 10 meters east of the fire hydrant. Let's say it's a person that's running from one side to the other. And then this is your D initial. Then the person, after some time, travels to 10 meters west of the fire hydrant. This is your D final. So your total displacement is traveling from this location to this location, D initial to D final. So you've traveled a total distance of 20 meters west. That is your delta D. Or we don't use directions, we use positive and negative signs, so that would be negative 20 meters. Now I'll show you how to do this mathematically. So we write out our given information. D initial equals positive 10 meters. D final equals negative 10 meters. Delta T equals 20 seconds. And our unknown is our velocity. So we use our equation, velocity equals D final minus D initial divided by time. And we plug in our values. So it's negative 10 meters minus 10 meters. And that gives us negative 20 meters, just like we saw in the diagram. That's our displacement, divided by 20 seconds. So the speed is equal, or the velocity is equal to negative 1.0 meters per second. And remember to always pay attention to sig figs in your calculations. Or we can write 1 meter per second west. At the end, you can put the direction sign in. But you don't write negative 1 meter per second west. So writing it like this, some students write it like this, negative 1.0 meters per second west. That would be incorrect. It's one or the other, either like this or like this, not a combination of the two. The equation for displacement can be rearranged to solve for D final or D initial. Delta D equals V times T. So we can plug in our values for D final minus D initial, so delta D rather. So D final minus D initial equals V times T. So this equation is just the equation that we got from the first part of the video when we rearranged for displacement. And then we're just plugging in the equation for displacement and substituting. And then we can rearrange this. We add di to both sides. So we get d final equals v times delta t plus di. Or we can rearrange this for di. Di equals d final minus v times delta t. Practice rearranging. As I mentioned before, you can always plug in numbers first and then rearrange it if that's easier for you. You will not have these equations on the test, so you have to know how to rearrange the equations. So here's an example. An object is traveling at 3 meters per second north. The initial position of the object is 20 meters north of a school. What will the position of the object be after 10 seconds? You can always draw a diagram of the scenario for yourself. So method 1 will use 2 steps. Step 1, calculate delta D. So we write out our given information. The velocity is positive 3 meters per second. D initial is positive 20 meters because it's 20 meters north of the school. Delta T equals 10 seconds, and our unknown is D final. The equation we're using is delta D equals V times delta T. So we can solve for delta D first, which equals 30 meters. And then step 2, we can calculate dF using the equation delta D equals D final minus D initial. So we plug in our values and we can rearrange and solve. So D final equals 50 meters positive 50 meters or 50 meters north. Now we're going to try solving it in one step. So we write out our given information and unknown. And then we use the equation for D final and solve it in a single step. And we get positive 50 meters. So depending on how comfortable you are with the math, if you're not super comfortable with the mathematics, then doing things in 2 or 3 steps is better because you'll understand it and you'll be able to do it. But if you're really strong with math, then you can do things in one step and skip a few steps along the way. And that concludes the presentation. Now you can try part 2 of the question worksheet.